Hey everyone. So what we're going to do today is applications of quadratic functions. So we've done applications before. We did some applications in vertex form. We did some in standard form. We also actually did some in factored form. So now we're going to do them where in order to solve for one of the questions that's going to ask, you have to do quadratic formula. So these are equations that are not factorable, that are not in a vertex form, and they are all in standard form. So we're going to go a little bit further than the questions that I had originally asked you. Just as a quick recap, also this graphic organizer is on Classroom. I'm going to give you a copy when I see you in person, but it should be helpful to find different things, help you find different things. So first of all, a lot of times it deals with an object being thrown up in the air, being projected. So it starts here. The object always starts at the y-intercept. So picture usually the x-axis is typically time, and then the y-axis is usually height. I mean, they're not always this, but picture like the object is this many feet off the ground. It's thrown up in the air, and then it goes down to the ground. So it reaches its maximum height. Remember, that's the vertex. So it even says right here at the vertex, the x value is when you would find the x value of the vertex when it asks you when is the object at its maximum height. Remember, the x value of the vertex is x equals negative b over 2a. And then the y value would be to answer the question, how high does the object get, or what is the maximum height? And that's when you would take the x value and plug it in to get the y value. Again, how high off the ground did the object start? That's always the y-intercept, which is your c when it's in standard form. And then a lot of times you're asked, how high is the object after blank seconds? And that's when you would just plug it in to the equation to get the corresponding y value. And then let's talk about the zeros. The zeros, remember, are the solutions. So when we do quadratic formula, it's you're given the zeros. So typically there's a negative one and there's a positive one. So the positive zero, this is what it represents. Picture, say it's a ball being thrown up. It goes to its maximum height. It goes down to the ground. This is where it reaches the ground. So over time, the x value would tell you, the y value is 0 over here because we're on the x-axis, but it would tell you how long it takes to hit the ground, or how long is it in the air. So all of this information that I just went over is also at the top of your notes, which is right here, things to remember. I gave you standard form, talking about how c is the y-intercept, x equals negative b over 2a is used to find the x-coordinate of the vertex. And then I even put underneath time it takes to get to the maximum height. Then you plug in the x-coordinate to find the y-coordinate, which is the maximum height or profit or whatever it is. And then to solve it, when it hits the ground or when y is 0, you do the quadratic formula. So we're going to do a few examples together. So here's our first example. Keenan launches a model helicopter. The height of the helicopter in feet is given by the equation. So here's our equation. Here's our equation where t is time and h is height. So it says, what can you tell about the flight of the helicopter by looking at the given function? And then I wrote, look at the sign of a. So if you guys remember, when a is negative, I don't know if you guys remember this, but when a is negative, it points down, opens down. So what can we tell about the flight of the helicopter? I would say that the helicopter goes up and then goes down. Parabola opens down because a is negative. That's how we can tell that. Letter B, after how many seconds does it take to reach its maximum height? So again, picture, here's the flight of the helicopter. It starts at the y-intercept. It starts at 190 feet. Picture, it starts here. It goes up to the top and then it goes down to the ground. So after how many seconds does it reach its maximum height? Here's the maximum height. That's the x-coordinate of the vertex. In order to get that, we need to use x equals negative b over 2a. So let's identify a, b, and c. A is negative 16, B is 64, and C is 190. Okay, so after how many seconds does it take to reach its maximum height? So we're going to plug in negative b over 2a. So it's going to be negative 64 over 2 times negative 16. And then you simplify. So negative 64 over negative 32. And then negative 64 divided by negative 32 is 2. And this is asking how many seconds. So we would say it reaches its maximum height after 2 seconds. So you just want to label your answer with whatever unit it is. Okay, C is what is the maximum height, which is the y-coordinate of the vertex. So what we're going to do here is we're going to take 2, x equals 2, or t equals 2, and we're going to plug it into the equation. So we're going to have h equals negative 16 times 2 squared plus 64 times 2. We're just plugging into plus 190. Okay, so now I'm going to do exponents first. So 2 squared is 4. So this is negative 16 times 4 plus 64 times 2. I'm just going to rewrite it all. Do one step at a time. Plus 190. So now left to right, I'm going to multiply. Negative 16 times 4 is negative 64. 64 times 2 is 128. So now again, I'm going to go from left to right. Negative 64 plus 128 is positive 64. Plus 190 would be 254. So this would be the maximum height. So after 2 seconds, it reaches its maximum height of 254 feet. Okay, the next one says, after how many seconds does it hit the ground? So we want to know, when does this parabola hit the ground? It starts here. When does this helicopter, rather? So it starts here, it goes up, it goes down to 0. So we want to know, what is the 0? What are the solutions to this quadratic? That's when you do quadratic formula. So I'm going to rewrite the A, B, and C down here so we have it. So it was A was negative 16, B was 64, C was 190. So we're going to take those 3 values and plug it into quadratic formula. So remember, quadratic formula is negative b, so negative 64, plus or minus big square root symbol, b squared, so 64 squared, minus 4 times a, which is negative 16, times c, which is 190, all over 2a. Whoops, I did not mean to do that. There we go. Okay, so now we're going to do 64 squared. So that's going to be negative 64 plus or minus, big square root symbol. 64 squared is 4,096. Then we're going to multiply these 3. Negative 4 times negative 16 is positive 64. Positive 64 times positive 190 is 12,160. And then 2 times negative 16 is negative 32. Okay, next we're going to add underneath the square root symbol. So we're going to have negative 64 plus or minus the square root of 16,256 all over negative 32. Okay, so the square root of 16,256, this is going to be negative 64 plus or minus, it's going to be 127.5 over negative 32. Okay, so at this point we can split it into the positive and the negative. So we're going to have negative 64 plus 127.5 over negative 32. And then we're going to have, so this is the first one, and then we're going to have negative 64 minus 127.5 over negative 32. So you always have your positive and your negative, and that gives you your 2 solutions. So let's take a look at this first one. Negative 64 plus 127.5 and then divided by negative 32 would be negative 1.98. And then negative 64 minus negative 120, not minus negative, minus 127.5 and then divided by negative 32 would be 5.98. So let's think about what this means. The question was, after how many seconds does it hit the ground? So could we have negative seconds? No, it doesn't make sense to have negative seconds. So this is your answer. We would say that it reaches the ground after about 5.98 seconds, or if you said about 6 seconds, that would be okay. Okay, so anytime it's asking how long is it in the air or after how long does it hit the ground, that's when you solve it. Whoa, it's not meant to do that. Okay, and then E is how high is the helicopter after 1 second? Plug it. So we're going to take x equals 1 or t equals 1 and plug it in. So t equals 1. So I'm going to have h equals negative 16 times 1 squared plus 64 times 1 plus 190. Now, a pretty common error here is kids want to do this first, the negative 16 times 1, but that's not what you want to do. You have to do the 1 squared first. So 1 squared is 1. Negative 16 times 1 is negative 16. Plus 64 plus 190. Negative 16 plus 64 is 48. Plus 190 would be 238 feet. So that means after 1 second, the helicopter is at 238 feet. So almost at its maximum height. Remember, it reached its maximum height after 2 seconds. Okay, so there's our first example. You kind of just like use the shape of the parabola to help you figure out what's what. Remember too that this graphic organizer from the beginning is really helpful. Okay, so let's see, we have 2 more examples. The next one does not have to do with the height, so they don't all have to do with the height. This one, it says the decreasing population, P, of owls in a national park is being monitored by ecologists and is modeled by the equation. So we have that equation. I'm just automatically going to identify A, B, and C because I know we're going to need to. A equals negative 0.4, B equals 128, C equals 1200. T is the number of months since ecologists started observing the owls. Okay, so if this model is accurate, when will the population of owls reach its maximum? So when will it reach its maximum? Notice that T, which is like X, is the number of months. So when will it reach its maximum? It's still going to follow a parabola. So when will it reach its maximum number of owls? That's still the x coordinate of the vertex. So this is still x equals negative b over 2a. So b is 128, so negative 128, negative b, over 2a, 2 times negative 0.4. Okay, so this is negative 128, and then 2 times negative 0.4 is negative 0.8. And then if you divide that, you get 160. So that would represent 160 months. So after 160 months, the population of the owls will reach its maximum number, maximum population. What is the maximum population? So what is this population of owls after 160 months? So we're going to take t equals 160, and we're going to plug it in. So population equals negative 0.4 times 160 squared, plus 128 times 160 plus 1200. Okay, so if I do 160 squared, you're going to do that first, and then multiply that by negative 0.4, you get negative 10,240. And then we can do 128 times 160 is 20,480 plus 1200. Okay, now that we've multiplied and done the exponent, we can add and subtract from left to right. So these two together would be 10,240 and then plus 1200, which your final answer, I'll write it over here, would be 11,440 owls. Because that is the population of owls after 160 months. And then the last question, determine the number of months it will take for the population of owls to disappear. So think about the number of owls starts here, it increases to its maximum after 160 months, and then it decreases all the way till 0. So this is where it would decrease to 0, and the number of owls would disappear. So this is, you have to solve it. This is a 0. Remember, to find the zeros, you do the quadratic formula. So I'm going to rewrite my A, B, and C down here so we have it. So A is negative 0.4. B is 128. C is 1200. Okay, so here we go. Quadratic formula, negative B. So negative 128 plus or minus big square root 128 squared minus 4 times A, which is negative 0.4, times C, which is 1200. All over the whole thing, 2A. So 2 times negative 0.4. Okay, so negative 128 stays the same. 128 squared is 16,384. And then if I multiply these three, negative 4 times negative 0.4, it's a positive, times 1200 would be 1,920. And then 2 times negative 0.4 would be negative 0.8. Okay, so continue up here. Next we have negative 128 plus or minus 16,384 plus 1,920 is 18,304. Again, over negative 0.8. Okay, now we need the square root of 18,304, which is 135.3. So this is negative 128 plus or minus that over negative 0.8. Continue again. So now we have negative 128 plus 135.3 over negative 0.8. And then we have negative 128 minus 135.3 over negative 0.8. So the first one ends up simplifying to negative 9.125, which remember, this is number of months. So can we have a negative number of months? No, we cannot. So that has to be eliminated because it doesn't make sense. You can't have negative time. And then this bottom one reduces to, if we do the top and then divide it by negative 0.8, you get 329.13 months. So wow. After 329 months, that's when the population of the owls would disappear, if it followed this trend. Okay, I think I'm actually going to stop there. I was going to do all three, but I don't want this video to drag on for too long. So what we will do is when I see you in class, we will start off with example 3, and we'll do example 3 together as a kind of a reminder. We'll go over these two that I already did again, and then we'll do some more practice. So if you'd like to try it, feel free, but I'm going to probably go over that in class tomorrow. All right, so that's it. So let me know if you have any questions. There is ACLab now, in case you didn't know, built into your schedule from 1:05 to 1:55. I'll be on my ACLab link on Zoom, so feel free to stop in if you have any questions or are stuck. All right, that's it. Thanks, guys. Have a great day.